Okay, so what I've done here is I kept up the start of the phase portrait that we had here. And over here, I just recopied the null lines with the equilibrium points highlighted. Because what I found is that naming the regions and then having the arrows, it starts to get a little bit crowded. So I'm going to use this to kind of give me that information, but then I'm going to draw my representative solution curves over on this cleaner graph over here. Okay. So I want to take a look at what happens if I start out in A. And remember, the possibilities are that you can approach an equilibrium point, or you can pass to an adjacent region. So I've got with A 3 different equilibrium points to consider, and 1, 2, because this is adjacent, 3 adjacent regions to consider. Let's see what happens. Let's start at the equilibrium points. So if I start here in A we're going up and left. That means I can't approach this because I'd have to go down to get there, and I can't approach this because I'd have to go right to get there. But I do think I could probably approach this equilibrium solution. So I'm going to draw something that's going up and right to approach that equilibrium solution. Now, if I follow this back in time, so you want to just make sure you're reading the directions on problems. If the problems say pick an initial condition and carry it forward, then you're fine. If they say draw a solution for all time, you want to follow it backwards in time as well. So I need to see where it came from. Well, if I'm always going up and right, I must have crossed into here from D. So I'm going to just extend this down, and so now I'm sorry, up and left. So I'm always going up and left, but I have to have gotten there by starting in D. So I'll pick this up when I get to looking at D, but that's where it had to come from. Okay. Let's look at whether we could pass into any adjacent regions. I can't pass into D. I can pass from D into A because I'm going up along this boundary line, but I can't pass into D. Can't pass into C because the only place where they touch is at this equilibrium solution, but I can't cross an equilibrium solution because solution curves don't cross. So can I cross into B? Nope, because once I hit this, I get shoved to the left. Okay, so if I'm in A, I'm approaching that equilibrium solution, period. Okay. All right, let's go ahead and take a look at D next, because we've got a curve here that carries into A. So obviously that's one possibility. Okay. Now with D, I've got these 2 equilibrium points, and I've got these 2 adjacent regions, A and C. We've already seen we can go into A. If we're in D, we're going right and up. So there's no way I can approach that equilibrium solution. I can imagine, though, going right and up and hitting this point. So I can certainly imagine that. And I can also imagine going right and up and then passing into C. So that also looks possible. Okay. So I could have, once I cross here, once I'm into D, now I need to recognize that here I'm following this curve backwards in time, because this curve was oriented this way. So where would this have come from? If in D I'm going right and up, following times backwards, I'd be going left and down. So that probably came from that equilibrium solution. Okay. Then I said we can imagine approaching this equilibrium solution. And again, if I follow it backwards in time has me going left and down. So everything that starts in D is really starting arbitrarily close to that equilibrium solution. And then we said I could imagine coming into D, so as long as, to C. So as long as I'm in this region here, I'm going right and up. Now once I hit here, I've got to have a horizontal tangent, and then what changes is I continue going right, but I've got to start coming down. So now I'm going to be coming right and down. And of course I'd have to level out because I can't cross this line, since here I know that y prime was 0 here. If I start on this line, I'm going to stay on this line and just go straight to the right. Okay. All right, so those are the solutions that I could get if I started in D. Let's take a look at C, because we've got a curve here in C. So for C, I've got this equilibrium solution, and I've got adjacent regions D and B. Now we've already dealt with D. We've seen that we can go from D into C. We can't therefore go the other way, because we can only cross these boundaries, these null lines, in one direction. Okay, so if I'm in C, I'm going right and down. So I can't approach this because this is the leftmost point. Okay. Can I go into B? Doesn't look like it, because to go from C to B, I'd have to be going up. So if I'm in C, I'm basically going right and down, period. No matter where I start, I'm going to be going right and down. So I'm going to be staying in C. So I've illustrated that with this curve right here that we carried over from D. So let's look at B. So if I'm in B, we're going down and left. So let's see, I see two equilibrium solutions here. Can I start in B and approach this one by going down and left? Yeah, absolutely. I just did. Okay, can I start in B and approach this equilibrium solution by going down and left? Yeah, I just have to start far enough over to the right that going down and left, I can approach this point. So it looks like I could approach either of those equilibrium solutions. Now, I don't necessarily know that all of these possible behaviors happen. I'm just saying this is what is possible based on the null lines. Okay, so could I start at B and go into A? Well, let's see, I'd be coming down and right. I'd have to have a horizontal tangent here, and then when I cross into A, I just change my vertical direction and go up. So yeah, that can happen. I can come like so. Whoops. My horizontal tangent is here, and at this point, I continue going right, but I start going up to approach this point right here. Could I start in B and go into C? Well, let's see. So I have to be going down and right. I could hit this point, hit a point on this null line, and then I'd have a vertical tangent. And what would change is that then I'd be going down and left. Left and right are so difficult, aren't they? I'd be going down and left. If I hit this line, I'm going to have a vertical tangent. When I pass into C, I'm still going down, but I'm going to switch to going right. So it would be coming down and left, vertical tangent here, continue going down, but start going to the right. So I would have something like that. Okay, so it looks like these are the possible behaviors that I have based on those null lines. Now, based on that, I could make an educated guess about the type of equilibrium solution I have, and in the next video, we'll actually classify them. So it looks like this one here, all the solutions are going away. I'm thinking this one's a source. So educated guess, 0, 0 is a source. This one, it looks like all of the solution curves here are approaching it. Now, I didn't look at what happened over here. Mathematically, this system is defined over there. We just said we were modeling a situation where everything was non-negative. So I don't know whether this pattern is true over here, but based on just what I see here, I'm thinking that's looking like a sink, so I won't be surprised if it is one. But I also recognize that I have limited information because I haven't looked at what happens on this side. Now, if I look at this point, I've got some curves that are approaching it, but then I've got other curves that sort of maybe are starting to approach it and then curve away. I'm kind of thinking saddle. So, educated guess, source, sink, saddle. I really am guessing here. I've done this problem years ago, but I haven't taught this class in a while. So in the next video, we're going to linearize these and see whether that's true or not. What I can tell you is that there's no way this could be a sink because it doesn't behave like a sink. There's no way that could be a source. So there are things that I can rule out and educated guesses that I can make. Let's linearize in the next video to see if those guesses are correct.